Hello everyone, and welcome at this transnational workshop about the CEDaCI project. I'm Victor Carpentier, and I'm a development engineer at T&D for Terra Nova Development. Inside the CEDaCI project, we're in charge of the servers and data centers characterization in order to define the recycling line of these equipments. So throughout this first presentation, I'm going to introduce how we characterize servers and how we determine their composition in T&D. So this characterization includes 3 steps. The first one is about the server dismantling. Then we are only focused on PCB and we prepare it and characterize it. And finally, after calculation, we can determine the composition of each PCB. So, first step is about the server dismantling. At the beginning of our characterization process, we have a server. And the first step is a manual dismantling. We dismantle each server parts by parts in order to sort each component according to the nature of these components. We can find 5 main streams inside a server. We can see this stream in the table. The first one is the metallic stream, about chassis, is about 70% weight of the total weight server. Then you've got plastics, 7%, cable, 2.5%, batteries 0.5%, and the most important, PCBs 21%. We dismantled by handled each servers because the most important is PCB. We characterize and we determine the composition of only PCB because scarce and precious metals are only concentrated inside PCBs. And moreover, it's very useful to know if a manual dismantling is a process that we can put inside our industrial process. So beyond this point, we are only focused on PCB. And with this PCB, with each PCB, we have to prepare it and characterize it. So the first step of the preparation is a manual cutting. We cut each PCB with a big and strong pliers, and we pyrolyze each PCB during 1 hour at 500 degrees Celsius. These pyrolyzes allow us to eliminate plastics contained inside PCB, and thanks to pyrolysis, PCBs become more crumbly. This crumbliness is very useful for the third step, which is shredding. We have to shred each PCB in order to grind it to powder. For big PCB, this shredding step includes 2 steps. The first one is a rough shredding with a big shredder, and the second one is a fine shredding. For small PCB, we only use fine shredding. And at the end of the 3 steps, manual cutting, pyrolysis, and shredding, we have a homogeneous PCB powder. And this PCB powder can be characterized by a sampling and acid digestion and analysis. So with this homogeneous PCB powder, we sampled it by quotation in order to have a sample which weighs about 200 or 300 milligrams. And then we mix this powder with strong acids like sulfuric, hydrochloric, hydrofluoric, or nitric acids. And we put this mixture inside a microwave, which raises the temperature at 200 degrees Celsius and the pressure at 60 bars. This extreme condition will digest our powder And at the end of this step, which is called acidization or mineralization, we have a clear solution without residue. We can see on the picture. And this solution will be analyzed by an ICP device. ICP for induct coupled plasma. This device gives us each concentration of each metal inside the solution. And thanks to calculation, we can know each weight percent of each metal inside our sampled and our homogeneous PCB powder. Okay? And after more and more calculation, we can know the average server's PCB's composition. This table gives us the average server's PCB's composition for each element. The most common element inside the server's PCB is copper. We can find 300 kilos of copper inside 1 ton of PCB. I draw your attention of the units of concentration, gram per ton of PCBs. We have to remember that the weight percent of PCBs inside one server is about 20 weight percent. So we have to dismantle 5 tons of server to have 1 ton of PCB. Okay? Then inside our PCB, we can find tin, nickel, lead, more interesting, tantalum, almost 1 kilo per ton of PCB. Also silver or indium, 180 gram per ton of PCB. And gold, 70 gram per ton of PCB. So these figures, these results are very, very interesting because we can see that the server's PCB are concentrated in interesting metal like gold, indium, or tantalum. But we have to treat server. We're gonna see this in the second presentation. And alongside of this analysis, the server's PCBs analyzed, TND analyze HDD's composition. We analyze HDD, and this table gives us the concentration of each element inside an HDD. We can find copper, 54 kilo per ton of HDD, and also really critical material, really critical metals like neodymium. We can find 1.3 kilo per ton of HDD, or tantalum, 1 kilo. Dysprosium and praseodymium, almost 200 grams per ton of HDD of dysprosium and 161 grams per ton of HDD about praseodymium. It's really, really interesting, but in the same way of servers PCBs, we have to know that the weight percent of HDD inside one server is between 1 to 3 weight percent. So we have to dismantle about 500 tons of server to have 1 ton of HDD. It's pretty huge. And moreover, HDDs are often removed from the server. The companies which own servers prefer to remove and to shred our HDDs at the end of life of their servers, because HDDs contain huge quantity of data, mainly confidential data. So company prefer to shred their HDDs. So we have to learn how many HDD we can get back for the CEDaCI project, because these results are very, very interesting, but we haven't an idea to how many HDD we can recover. So that's it for the characterization, the PCBs and HDDs characterization. Thank you for your attention.